Hey guys, today I'm just going to go over your study guide. By the end of this video, you're going to be able to review systems of equations, and I want you to really focus on your areas of improvement. So don't focus so much on the things you're really good at. Focus on the things you need help with, and let's get those figured out today. So go ahead and turn to your study guide using the math section of your binder and get ready to look at your notes. All right, so the first thing you should be able to do is solve a system of equations by graphing. So number one says write the equation of each line graphed at the right. I always think I begin at the b, and since our format for linear equations is y equals mx plus b, where b is your y-intercept, then you want to start by looking at line A when it crosses the y-axis. So that's at 8. And then the slope is the m. It's how it moves. That's the rise over run. So from the y-intercept to the next point here, it's going up 2, 4, and then over 8. Again, because it's going by twos here on each axis. So up 4 over 8 simplifies to be 1/2 or 1 over 2. So when you write your equation of a line, you always start with y equals, and then instead of writing m, you write the slope, which we just found was 1 over 2. Keep the x, plus where you begin on the y-axis. The starting point was at 8. So y equals 1/2 x plus 8 is the equation of line A. We'll do the same thing for line B. I can already tell you it's going to have a negative slope because it's going downhill. And if I put myself on a dirt bike on it, I'd be going down. So we begin at 16 on the line B, on the y-axis, and it's going down and over to get to this point. So to get from point to point, it went down 4 from 16 to 12, and then over 8. So 4 over 8 also simplifies to be 1/2. Since it's a negative slope, it's going to be a negative 1/2. You can also think since you went down and to the right, down is negative. So y equals negative 1/2 x plus 16. Now the question number 2, it says, what's the solution to the system of equations? A solution to a system is where they intersect. It's the point that they cross at. So you always write your points as x comma y. And since it's going over on the x-axis to 8 and then up to 12, the solution would be 8, 12. Let's look at question 3. Use this space here to prove that the solution to the system makes sense for both these equations. So I'm just going to do it one step at a time. So line A, this is just a checking step. Line A has this equation. And instead of writing x and y, I'm going to use this point 8, 12. So instead of writing a y, I'm going to write 12 since that's the y. Instead of writing times x, I'm going to write times 8 since that's our x. Now that I've got it written like this, I'm just going to solve it and check it. So half of 8 is 4 plus 8 is 12. 12 equals 12. So I know that line A's solution of 8, 12 makes sense. It should also work for line B. Line B said y equals negative half x plus 16. So I'm going to do the same thing I just did for line A and plug in these points for x and y. When I do that, I get that 12 equals 12. And that checks out. So if you can do questions 1, 2, and 3, you're good at graphing the systems of equations and then checking to make sure that that solution works for both equations. Let's look at number 4. It's another question about graphing. You have y equals 6 and y equals 3x minus 3. Let's start by color coding each of these lines. Y equals 6 is going to be the blue line, and y equals 3x minus 3 is going to be the red line. The blue line of y equals 6 means that I'm going to start by putting a point on 6, and then if you notice, it's 6 all the way across. The graph of a horizontal line of y equals 6 looks like this. The red line is y equals 3x minus 3. I want to begin at the y-intercept of negative 3, and then use my slope of 3 to determine where my next point is. So I count up 3 over 1, up 3 over 1. And I keep doing that until my points cross. If you notice, my points already have a cross here at this point. That point is at 3, 6. So the solution to the system of equations in question 4 is 3, 6. And you always write your solution as a point. Number 5 says to solve the system of equations by graphing. If you have an online calculator, you can put these both in, and you would notice that they are the same line. You also can look at this, and you can see that if you solved it by inspection, they would have the same slope and y-intercept when you change this second equation into slope-intercept form. However you do it, you'll end up with infinitely many solutions for these two equations, and your graph will look something like this. Let's look at question 6. If you struggled with question 6, you probably struggled with this second equation. Having a slope of 1.5 is a little more difficult to graph. We like to have it as rise over run as a fraction. So the first thing I would do is rewrite that second equation. Instead of 1.5, I can write that as 3 over 2. That's more helpful because you can graph it as rise over run. way better than just 1.5. That's kind of confusing. So keeping that in mind, I'll go ahead and graph the first one for you using it as a blue line, and the second one we'll do in red line. I begin at the y-intercept of -3, and then it's going up 1, over 1. I'm going to plot as many points as I can on this graph. So that's as many plots as I can point, and then points as I can plot, and then I'm going to connect the dots and make a little rough line. Now I'll do the red line. I'm going to use this equation because I'm going to start at -5, and then like I said, it's a lot easier to go up 3 over 2. So I'm going to go 1, 2, 3 over 2. No solution yet, so I'm going to keep going. Up 1, 2, 3 over 2, and you can see I have a solution here at 4, 1. That point makes the graphs look something like this, and that point is where they intersect, so that's our solution. Let's look at number 7. Whether you solve this with a graphing calculator or you solve it by inspection, making sure that you make this second equation in slope-intercept form, you're going to realize that there is nothing that you can put in for x or y that could make these equations work. They're going to look like parallel lines, and they're going to look something like this. Not exactly, but they're parallel and they're going off in the same direction forever and ever and ever. They're never going to intersect and they're never going to cross. This is an example of an equation, a system of equations where there's no solution. Okay, so let's move on to number 8. This is a system of equations by graphing, but we have a word problem. So it says that Ralph's T-shirt company sells T-shirts for $7.50 each with a flat rate of $10 for shipping. I'm going to underline $7.50 each. I'm going to underline flat rate of 10. Frank's T-shirt company sells T-shirts for $10 each with free shipping. So you have Ralph and Frank comparing their T-shirt companies. When you're comparing two companies, you're looking at a system of equation. The first part of this says write an equation that represents each T-shirt company. So I underline some important words. When it says something's by something or each, that's going to be our slope or our M. Because remember, the slope and the M, that's another way to say rate or unit rate, like we learned in 7th grade math. The flat rate is a upfront cost. That's not changing. So that's where you begin whenever you're looking at this. That's going to be our B, our y-intercept. So the same thing would be true for Frank's. But let's start with Ralph's. Since it says 750 each, that's our M. I'm going to write this as y equals 7.5x, because those are the number of T-shirts, plus 10, because that's where you start. You start with the 10 plus 750 each. Frank's is $10 each with free shipping. So he's going to have a y equals 10x, but he's got free shipping. So you could put plus 0. Since we know plus 0 is just nothing, I'm just going to leave it as y equals 10x. Frank's graph will be proportional, and Ralph's will not, since he has a starting point. I'm going to do Ralph's first in green, and then I'm going to do Frank's next in red. So Ralph starts at 10, and he goes up 750 for each shirt. I think the easiest way to look at this would be to generate a graph or a table for this on a calculator. So I just generated this table real quick. If you didn't want to generate this using a software like a calculator or an online program, you could go ahead and just create this yourself by plugging in 1 in for x, 2 in for x, 3 in for x, and so on. I want to focus on the points that give me whole number values for y. Now, I'm only focusing on those because for the purpose of graphing this, I'm only given whole numbers. So these points are going to actually be the more important points, especially the 10, the 40, and the 70, because it's going to match the graph units here. Like the scale over here is going by tens, so I want my y's to go by tens as well, just for the sake of the graph. So give me a second, I'll graph this for you. Okay, so as you can see, I've plotted the graph of this line, but I've plotted these 3 points in particular because these are the points that have, again, a whole number of values that are in the tens place for the y. Okay, so now let's look at Frank's graph. Frank's is a lot easier because his is $10 per one shirt, and it's proportional, so it starts at 0. Remember, he has free shipping. So 10 for every one shirt means that I can just put up by 10 each time. Already you can see that I have a solution to the system here at this point. So the problem with graphing is that it looks like there might be another solution at 550. It's really at 440. That's the problem with graphing, is that it's not going to be perfect. You just got to get as close as you can. And especially if you have, like I said, some sort of graphing software, that would be the best way to do this, by graphing. So the solution is at 440. In context, that means, what does it mean with the problem? What does that mean with the shirts and the money and all that stuff? Well, it means that Ralph and Frank's t-shirt shops shall charge the same amount of $40 after 4 t-shirts. All right, so the next set is solving systems of equations algebraically. That's by substitution, and then later on through elimination. Now, if you still have a graphing calculator that will graph this, even though it's in standard form, you can still graph these to find your solution. However, I am going to go through these by substitution and algebraically because that's what this section tells me I should be able to do. So on number 9, it says solve the systems by substitution. That means since I know what y equals, I can put in what y is here, 1/2 x minus 5, in for the y in the second equation. I'm going to do that on a separate sheet of paper or a separate page, so you should as well. So I already substituted in my value for y into the value of y in the second equation, and now I'm just going to distribute to solve. I got this, and then I want to combine any like terms. I see I've got x's over here, so I'm going to combine those right now. Now I have a two-step equation, so I need to start solving for my x. I'm going to do that by using inverse operations. So I need to get rid of this minus 15. That means I need to add 15 to both sides. That leaves me with a 2.5x on the left and a 35 on the right. I divide to solve for x, and that gives me a solution of x equals 14. So I have my missing x value, but I need to find my missing y value. Remember, a solution to a system of equations is going to have an x and a y value. So let me go ahead and solve by plugging in x into one of these equations. I'll choose the second one. I rewrote the second equation, where instead of writing an x, I wrote 14. Now I'm going to solve for y. I'm going to subtract 14 from both sides, and then I'm going to divide by 3. That gave me a value of y equals 2. So my solution to this system is 14, 2. Let's look at number 10. Now, I normally wouldn't solve this one by substitution. I would solve this one by elimination. You can do that if you want to. If you want to solve it by substitution, because it says to, that's fine. But you can also graph it or solve it by elimination because you know all those methods. I'm going to do what they told me to, so I need to get one of these variables isolated. I need to solve the first equation for an x or a y. So instead of x plus y equals 8, I'm going to write y equals 8 minus x. It's the same thing. It's just written differently. So now I'm going to plug what y equals here into the second equation. This is what it is after I substituted in this for y. Now I'm going to distribute the 2. I'm going to combine like terms on the left side of my expression or equation, excuse me. 3x minus 2x is just 1x. I'm left with a one-step equation to draw my line on the equals and solve. It's plus 16, so I'm going to subtract 16. So x equals negative 8. I'm not done yet because I only found my x and I need to find my y. So if I know that x is negative 8, it has to add to 16 to give me a positive 8. So 16 would be my y value. Negative 8, 16 is the solution to the system of equations here. Let's look at number 11. It says solve the system of equations by substitution. I know that y equals 5 6x plus 2. I'm going to plug that in for the y in the first equation. When I do that, this is my equation. Now I know I need to start by distributing that 6 to each of these terms on the inside. I got 5x plus 12 after I did that, and I'm going to bring everything else down. Now I'm going to draw my line on the equals and simplify what I can on the left. I see negative 5x and 5x. Those are like terms. They go together, and I know that they cancel out. Negative 5x plus 5x makes 0. So I'm left with 12 equals 12. Since that is a true statement, it doesn't matter what I put in for x and y. It will always come out to be equal. That means that there are an infinite number of solutions for this because actually these are the same line, just written differently. And for your answer, you just have to write infinitely many solutions. Let's continue working through these and look at number 12. It says solve by substitution. Again, you can solve by any method you want, and because they're on top of each other here, I would use elimination. But if you want to do substitution, we'll do it. So we're going to start by isolating one of our variables. I'm going to get the x by itself in the first equation. So instead of writing x minus 2y equals 19, I can write that as x equals 19 plus 2y. Now I'm going to take what I know x equals and plug it in for the x in the second equation. So I substituted in what x equals into the x in the second equation. Now I'm going to start by distributing that 2 on the outside to each of these terms on the inside. So I'm left with 38 plus 4y plus 1y. I'm going to combine my like terms. I know that these y's go together. And now I have a two-step equation to solve. So I'm going to start by getting rid of that plus 38 by subtracting 38, and I do it to both sides. And now I have a one-step equation. I finish this out by dividing by positive 5. Negative 25 divided by positive 5 equals negative 5. So that's my y. But I do need to finish this by solving for my x. So I'm going to plug in a y of negative 5 into this first equation. This is what that looks like. Negative 2 times negative 5 is a positive 10, and that equals 19. 9 plus 10 equals 19. So 9 is my x value, and 9 negative 5 is my solution to this system of equations. Let's look at the next one. It's already set for y. So I'm going to put in what y equals into the y in the first equation. So rewrite this and put it on a separate sheet of paper. This is what your equation should look like. You want to start by distributing that 8 to each of these terms on the inside. This is what you're left with. You get negative 4x plus 40. Now you need to combine your like terms. 4x and negative 4x are like terms, and they combine to make 0. So I can cross those out, and I'm left with 40 equals 24. This is not a true statement. However, we did our math correctly. That doesn't mean we did it wrong. It means that there is actually no solution we could put in for the x or the y to make these equations true. So for this one, they're going to be graphed parallel to each other. And if you want to, you can put no solution, or you can put D N E, does not exist. So either of those would be acceptable answers as long as you make it clear to me that there is no number you can put in for x or y that would make these true. There's no solution here. Let's look at number 14. I have a y equals. Since y equals 5x minus 4 in this one, I know that I can put 5x minus 4 for the y in the second one. After you substitute, that's what this should look like. You draw your line on the equals, and you start by distributing first. This is what your next step should be. Then you want to combine like terms on the left. 4x and 10x go together to make 14x. Now I have a two-step equation. I'm going to start by getting rid of that minus 8 with a plus 8. After adding 8 to both sides, I got 14x equals 42. I need to divide by 14 to get the x by itself, and I'm left with x equals 3. If x equals 3, then I need to take that x in the first equation and substitute it with a 3. 5 times 3 is 15, minus 4 is 11. So when x is 3, y is 11, and this would be the solution to this system of equations. The next section is going to be solving these by inspection. That just means we're going to look closely at these and see if we can recognize patterns or use logic to determine whether there is one solution that can be solved for, no solutions, or infinitely many solutions. So let's start with number 15. These two guys have equations that are the same slope, but Aaron's y-intercept was negative and Blake's was positive. If they have the same slope but a different y-intercept, they would be parallel. They would never intersect, and so therefore they can have no solution. So they have to be no solution because they are parallel lines. If you graph them, they would never, ever intersect. Let's look at number 16. I see that I have an equation written in slope-intercept form. Remember, that's whenever it's written y equals, but the other one I don't. I'm going to make the other one in slope-intercept form so that way I can compare them easier. So for the first one, I have 6x plus y equals 8. I can rewrite that as y equals 8 minus 6x. Since the y-intercept is 8 for both of these, and the slope is negative 6, these are actually the same line, just written in different forms. That's why there are infinitely many solutions to this system of equations. Let's look at number 17. I see x plus y equals 7 and x plus y equals negative 7. That's not possible. There's nothing I could put in for x and y that would make them equal different numbers. So for this one, there'd be no solution. And again, the inspection method just means that I can tell that just by looking at it and using logic. Let's look at number 18. I have different y-intercepts and different slopes. I know that there will be one solution to that since there are different y-intercepts and different slopes. I can actually solve for that solution, but I'm not going to for this. It's enough to know right now that there's just one solution to this. And the lines will intersect at one point. Let's look at number 19. 19, I have two equations, but they are written differently. They're both in standard form, and actually what I want to use for this one is I want to think about these like we did with our elimination method. Let's manipulate the first equation to see if it matches the second one. I can tell already that if I took the first equation and multiplied all of it by 3, I would end up with 3x plus 3y equals 18. This equation and this equation are the exact same. If I were to graph this, they'd have the same slope and the same y-intercept. And if I were to solve it by substitution, I would end up with one number equaling the other number. That's because there are infinitely many solutions because these two lines are the same. All right, so one of the last methods we learned was by elimination. And this is my favorite one because when I have these two equations lined up by term, x's and y's, and numbers are on top of each other, and I have something that cancels out like I do here, an x and a negative x, I can just add these up. X minus x cancels, so I can just cross that out. 5 minus 2 is 3y, and 19 minus 4 is 15. Now I'm thinking, what number times 3 gives me 15? Y equals 5. Since I know y equals 5, I can put in a 5 for the y in either one of these equations. I'm going to choose to use the first one because, I don't know, I just chose to. I like it better. And you can choose either one you want to as long as you put in a 5 for the y. So x plus 5 times 5 gave me 19. So x plus 25 equals 19. And then subtract 25 from both sides to get a value of x equals negative 6. So your solution to this system will be written as an ordered pair, negative 6, 5. Let's look at number 21. These don't automatically cancel. So I need to manipulate this second equation so that it can cancel because I know I have a negative next to the y and a positive next to this y. So if I can get 5 to 10, these will cancel. The way to get to from a 5 to a 10 is to multiply by 2. I'm going to multiply the whole second equation by 2. So this equation right here is this one multiplied by 2, and I just brought down the first one so I could line them up neatly. So I'm going to add them. 3x plus 2x gives me 5x. The y's cancel, and that equals the sum of negative 84 and 40. Negative 44, so that means that x equals negative 44 divided by 5, which is negative 8.8. This is wrong on the study guide, so if you got to this part on the video, you realized there was a mistake on the study guide answer key. If you did that, I want you to email me the word apples, and I'll give you an extra bonus 10 points on the test. All right, so I found my x. Now I need to find my y. So I substituted it into the second one. You can substitute it into either one of them and solve for y. I got y equals 5.76. Again, wrong on the study guide, but if you got to this part in the video because it looked like you missed that on the study guide, then again, email me the word apples to get a bonus 10 points. So this would be the solution to your system of equations in 21. Let's look at number 22. It says 4x minus 8y equals negative 4, and you have a negative 2x plus 8y equals negative 2. Already I can tell that these are going to cancel on the y, so I'm going to cross them out, and I'm going to add everything else. So 4 minus 2x is 2x equals negative 4 minus 2, or plus negative 2, which is negative 6. So x equals negative 3. I need to solve for y now. When I do that, I just substitute in the value of x equals negative 3 into either one of these equations, and then I solve and simplify. So your first step, then you need to add 12 to both sides. You end up with y equals negative 1. So your solution would be negative 3, negative 1. All right, so I'm not going to read this to you. You can read this to yourself. But the problem that we have here is that when she wrote the system of equations, it looks like she wrote x is like 10. There's 10 more. It says here there's 10 more quarters than dimes. But she wrote that x is the quarters in the first equation. In the second one, x is now dimes. So she's mixed up her variables. You need to define your variables and keep them consistent throughout. You can say something like she didn't keep her x and y definitions consistent. She changed them. They were dimes, they were quarters. She mixed it up. Let's look at number 24. We're going to write a system of equations from this word problem. So go through it and underline anything you think is important first. I know that the small is $2, large is $3.50. So you might want to write that down off to the side. She sold $163 together. And you also know that the number of large snow cones sold 12 more, than the number of smalls. Doesn't matter what variable you pick. I'm going to choose x for small, y is the large. So 2 for every x is the small, plus 350 for every y, which is the large. She made a total of $163. So this equation is all about the money. The next one's going to be about the quantity, the number that she sold altogether. She sold 12 more than the smalls. So x plus 12, or 12 plus x, equals y. Because we know what y equals, I would substitute in x plus 12 in for the y in the first equation, solve by substitution, and get my answer. But you can do it whichever way you like best. When you do that, you get a solution of 22, 34. 22 small, 34 large. Let's look at 25. Supplementary means that the angles add up to be 180 degrees. So I know that I can write that first equation as x plus y equals 180. The larger angle is 15 more than 10 times the smaller angle. I'll make the smaller angle x and the larger angle y. 15 more than means 15 plus. 10 times the smaller angle, which is x, gives me y. Since it's set equal to y, I'm going to put what y equals into the y in the first equation. Then I'm going to solve. When you do that, you get that the smaller angle is 15 degrees and the larger angle is 165 degrees. Let's look at the next one. It's another geometry application. She put 200 inches along the border of a rectangular bulletin board. If the length of the border is 4 times the width, then what are the dimensions? So the first one's talking about perimeter. And a picture might help you understand this shape. So the first one's the perimeter. I know that the length of the x sides added up, so 2 times the x plus 2 times the y, gave me the perimeter of 200. The second one's about area. It says that we know that the length of the bulletin board, which is the y's, so y is 4 times the width, so 4x, since it's 4 times the size of that. Since I've got it set y equals, I'm going to put what y equals, which is 4x, into the y in the first equation and then solve. When I do that, I got a solution of 20, 80, which means that 20 is the width and 80 is the length. So this measurement is 20, this one is 80. You should always plug those in to check. Let's look at 27. This one is just like math words for a pretty simple equation here. There's two numbers, we don't know them. One of them is 10 more than 3 times the smaller number. Let's write that as an equation. Let's break it down. One number, let's just call it x, is means equals 10 more, which means add, 3 times another number. Let's just pick y. Let's look at the second one. It says the larger number, that's what we decided x was, the larger number x decreased, that means minus, so decreased by minus the smaller number, which would be our y, is equals 80. What are the two numbers? Since I have what x equals, it's 10 plus 3y, I'm going to put that in for the x in the second equation. Then I'm going to solve for x and y. When I do that, I get that the larger number x is 115 and the smaller number y is 35. I plug those in to check. I know 115 minus 35 gives me 80, and I know that 3 times 35 plus 10 gives me 115. All right, guys, that's it. If for some reason you watched this whole video and you made it to the very end, maybe you're confused on some stuff. If you are, you don't need to comment that. You can just message me or email me or come talk to me in person and let me know, and we can try to get you figured out. Today, I went over your systems of equations study guide. So now you should be able to review systems of equations, and hopefully you focus on your areas of improvement. And like I said, if you still have those, please reach out to me. Let me know if you have any questions. Bye.